In today's lecture, we will study to design timing diagrams for 8085. Like for this case, firstly, I'm taking one example. Like suppose I need to design a timing diagram for move A, comma B. This instruction may be placed at any address. For example, it is placed at 8000. That is the address. 80 is the high order address here. A, suppose A8 to A15, and 00 is the low order address that may be stored at the pin AD0 to AD7. And move A, comma B is used to move the data from B register to A register. That is 78H. That 78H is the opcode value which you need to fetch when the contents of B register is transferred to the A register. So in this case only opcode fetch is required. So only one machine cycle is required when we need to fetch the opcode. One machine cycle. So for this machine cycle, 40 states are required to fetch the opcode. And one of most important signals which we need to know, that is A8 to A15. Whenever we need to design the timing diagram, AD0 to AD7. For this case, AD0 to AD7 maybe, this is a multiplex address data bus. It depends upon ALE signal. When this signal is 1, then it is used to read low order address, that is A0 to A7. When ALE signal is 0, then it is used to read the opcode, that may be 78H. And high order address is your 80H. And after that, we have a selection signals like S0 and S1. If it is 00, then no operation. If it is 01, then it is used for write operation. And if it is 10, it is used for read operation. And if it is 11, that is for opcode fetch operation. And one of the signal is IO/M complement. When you need to read the opcode, it should be 0. And another read signal should be 0 when you need to read the data from the memory. So now we'll start the timing diagram for move A, comma B instruction. Like you need 4 T states, like suppose I'm taking the 4 T states here. For example, this is the clock signal, and I'm taking the clock signal here. First, I need to take the high order address, that is suppose A15 to A8. These are the pins, which is already we discussed in the pin diagram. And it used to, this is a T0, T state, T1, T2, and T3. It will take one T state to read high order as well as low order address. For this case, we can take either one T state, or it may be on the bus for 3 T states. Like this is for on the bus for 3 T states. After that, it may go unspecified. Then this is the, what is the value for high order address? In this case, we are taking 8000 is the address, and 78H is the opcode to transfer the data from B to A register. So what is your high order address here is 80H. After that, we need to take low order address, that is AD0 to AD7 pin is used to read low order address as well as opcode. For this case, again we need to take first clock cycle used to read low order address, that is from A0 to A7. Now in this case, it is 00H. So after the 1 T state, there may be after some delay, and this line also, this pin also used to read the data, or maybe the opcode read, that is 78H. And it depends upon the ALE signal. When this signal is 1, then it is used to read low order address. When this signal is 0, it is used to read opcode. And here T0, T1, T2 states, T0 is T0 basically it is used to read high order as well as low order address. And after T1, the instruction will be stored into IR. And T3 is used for, why we have to write here unspecified, or it is used for decoding and execution. T3 is used for instruction decoding and execution is done in T3 T state. ALA is 1, then load address would be read. When it is 0, opcode fetch would be, opcode would be read. Then after that, it also depends upon the read signal, and read signal, your read signal should be 0. When you need to fetch the opcode at that time, it should be 0. So for this case, it should be 0. At this time, actually, the opcode would be fetched. And IO slash M complement, this signal should be 0 because we need to read the opcode from the memory, and this signal needs to be low for every T state. And after that selection line, it should be 1, 1. So either you can write in any way, either you can take in different way, or I have to write in this way. The selection line should be S0, S1 should be 1, 1. Then you need to fetch the opcode from the memory. So this is a timing diagram for move instruction, and you can design any timing diagram for 1 byte instruction. Thank you for watching this video. In next video, we'll study how to design a timing diagram for move M, any register, for example, P register.